Hi everyone, I'm Simon. I'm the CEO and co-founder of ScarabTech.
And don't gloss over.
Don't gloss over.
Yes, you can.
Is it good?
Yeah.
Okay. Would you like to introduce yourself?
I thought you weren't going to gloss
No,
over.
I'm going to gloss over.
Okay, cool.
I'm going to gloss over it for
Right,
now.
and I'm Craig, the COO of ScarabTech now. I found ScarabTech because of, as Julie mentioned, a project to create economic localization in communities where we were looking at various products that could uplift communities. It started during COVID. We looked at water projects, we looked at community internet service providers, we looked at things like biochar, and each of those are very difficult to work on their own. They can't wash their own face on their own. But as we started stacking them up, they actually start to make sense. And then ScarabTech can actually fuel all of them. So it is the most exciting thing that I've found in the last couple of years.
Thank you.
So cool.
Thank you. And a little bit about me. We got into this problem because, if you look around where we are now, it's easy to imagine that there isn't a plastic problem at all, or that the solutions exist because if you look out the window, you don't see any plastic. But even in a place like Zurich, the exit to the lake and the river coming in, they've got plastic traps because there's plastic in the rivers, even here in Switzerland. And in places outside of very wealthy nations in Europe and America, which have often, it looks like they solved the problem, but actually they just sent it to us, in the third world. And okay, this is me. That's me. And this is, in 1984, this is a river in Johannesburg that we used to go up once a month, me and my cousins and friends and my dad, and you'd go and swim in the river.
And I went there in the late 70s. So
Yeah. All right.
it was even cleaner.
This is the same river now. That's the same place. Yeah. And so it's, when this is happening in your backyard with places that have got some sort of, nostalgic value as well as just, I can't even take my kids to the river. You end up wanting to do something about it. So it was really friends, we were all discussing exactly this kind of problem. And we were on a friend's farm and he had a biodiesel gasifier where, you took farm waste and you threw it in and it made gas and we were like, well, we were just talking, we were like, well, why couldn't you just put plastic in a biodiesel gasifier? They're both hydrocarbons, the ones, it should work. So we sort of sat there and fed a few pieces in and nothing happened. And then we did a bit more research and we worked out, no, this is possible and you can totally do it. So we looked around and we're like, well, why don't we just build a machine? We build a small one, a proof of concept, just to, just as a sort of education project. And we looked for grants and we got one. We got our first money from Burning Man, which if you've been will not surprise you, and if you haven't, it might. So that was the first one, and it's a giant dung beetle, and if you look over here, that's the machine, and it's built from old boiler parts, and it was put together. I mean, it looks like something out of Mad Max, right? It's great, and the thing we told Burning Man is we're going to take the waste plastic, we're going to turn it into gas, we're going to run a generator, the generator's going to run a sound stage, and we threw parties. So there were plastic parties. And we've been doing this every year since 2018, 2019. We make a whole lot of fuel, we take it down to Burning Man or Africa Burn, and we give it away, and all the art cars can come and get free fuel, and we throw parties, and yeah, that's me.
And he wears that often.
I mean, I like parties. And then people kept coming up to us and going, what the hell is this machine? And then you'd explain pyrolysis, and then they were like, well, where do we get one? And we're like, no, this is really just an education project. You can't have ours. There's only one of them. And we got asked enough times that we said, all right, well, maybe we should make these, maybe we should try and make them. So we set up ScarabTech, and ScarabTech is called Scarab because a dung beetle is a dung beetle, and dung beetles clean up shit. So that's why it's called that's why it's called ScarabTech. And you know, we made them bigger. The first thing was like, well, this thing has to be bigger, and we only made one bigger, and we immediately went back and started making them smaller and smaller. And there's a reason for that.
So why is there a demand for small plastic processing?
Yeah, why is there a reason for small, tiny machines? And to answer that, we kind of have to backtrack a bit, because there's a lot of misconceptions about both plastic and what happens to plastic. You know, and what the solutions are. The solutions that most people think of are not really true. So I'm going to fly through some quick things. The 2-hour version of this could be 2 hours, so I'm going to zoom through some slides. But the first thing is, I'm not anti-plastic. Plastic is fantastic. Like, it really is. It's just the most incredible material, and it's got a great ecological pedigree. The first plastic is probably the reason we have elephants. The first plastic was celluloid, and it was made from plants, but it was made to make billiard balls, which until that point were made of ivory, and they were running out of elephants to make billiard balls, and this James Hyatt came up with this substance, and it replaced billiard balls and saved the elephants. And then they worked out that oil was way better at making these products than plants, because oil was like a Lego set of thousands of different hydrocarbons that you could put together and change and move around. It's like a big Lego set with every single Lego brick ever invented. Whereas a plant is sort of, you know, there's a few little Lego bricks, so it's much harder to build what you want. But with oil, oh my God, you could build the most amazing products. And we didn't just replace ivory, we replaced feathers and leathers and furs and, you know, all of those things that you see now. You know, there's a good reason that a lot of animals were saved by us finding plastic versions of the things we used to have to kill them for. Unfortunately, we also replaced a whole bunch of stuff that's actually quite ecologically friendly and completely sustainable. So, you know, cottons and bamboos and wools and sheep, not sheep, wools and silk. And, you know, so we started off replacing, well, we replaced lots of stuff that was great, and then we started replacing everything, and now everything just got replaced by plastic. And yeah, I mean, there's a good reason for that. It's unbelievably cheap. It's cheaper and it performs better. It's just a better material. And not only could we replace woods and steel and like everything, glass, you could make all these magic materials, you know, like Teflon and Gore-Tex, you know, materials that, you know, lets vapor out but not liquid water in, you know, things that really incredible. And, you know, the thing that amazes me more than anything else is that we're taking this giant Lego set to make amazing materials, and most of it gets set on fire, which is really unfortunate. But plastic has one huge problem, and that is it lasts way longer than we need it to last for most of the things that we make. So, you know, we've made plumbing that'll probably last 1,000 years, longer than sort of old Roman plumbing. But we've also made nappies and cigarette butts. They also last 1,000 years. And the plastic spoon and the chocolate wrapper and like everything lasts the same amount of time. So this is a quick graphic. It's like, this is all the plastic that's ever been made. And that is the amount that just goes, it gets buried or just tossed into the environment, discarded. That much is incinerated, and, you know, that's what recycling looks like.
And this is what people don't believe and don't see, is that that's all that gets recycled.
Yeah, and it's worth sort of drilling down a little bit more, but basically we've got this problem. And when we made the first machine, that number was 5 billion in the environment. It's now 6, and this was 240 million tons dumped each year. It's now 364. This is in 5 years. So, you know, in a few years, this is going to be 7, 8. It's stratospheric. And as we know, it's got endocrine disrupting issues, all this plastic and plastic bottles. But beyond that, it's just leaches and chokes ecosystems. You saw that river. It's very difficult to actually rehabilitate a river that's just been completely ruined. And the issue is that the plastic is everywhere on Earth, because every product is either plastic or came in a plastic packet. So the plastic's everywhere. But the solutions are not everywhere. And this is what actually happens to plastic. About half winds up buried, 22 mismanaged, that means tossed in the river, incinerated, set on fire in the open air usually, just because what the hell are you going to do with it? You can toss it in the river while no one's looking, or you can burn it while no one's looking. Like, those are the options. And here's recycling.
Yeah.
Yeah.
And in the communities we work in, that incineration thing is horrific. I mean, you drive into these communities and there's just fires all
Plastic
over the
everywhere.
show,
Yeah.
with the plastic being burnt. And imagine if we could get them to see that as money, which is what we're trying to do.
Everyone see it as money, because
Yeah.
plastic has double the energy density of coal, and we still dig coal. It's kind of crazy. But the thing, we're told constantly it's, reduce, reuse, recycle. That's the mantra. It's been like that since, well, reduction doesn't work because plastic accumulates and lasts without. So, okay, you kick the can a bit down the road. Reuse, okay, cool, yes, we should do that too, but still it accumulates and eventually it gets discarded and you're kicking the can further down the road. So then the thing is like recycling, that's the one. And recycling for plastic is bullshit. It's just not true. It's true, but it doesn't solve anything.
And the sad thing is, you talk to recyclers and they're actually anti our solution, because they say, no, we just keep recycling, we can recycle.
Recycling it, yeah.
Meantime, they don't know that you can't keep recycling. It's not indefinitely recyclable.
Yeah, so there's three problems with recycling. The one is that most of the plastic you see isn't recyclable. It's just not. It's not, you can't process it. So landfill or incineration. And even the plastic that's recycled is not infinitely recyclable, so after about 3 or 4 cycles, you've got to throw it away. It's not like aluminium or glass. It's not infinitely. So eventually it all gets discarded. And then, okay, well, what happens if we could make it all recyclable and it could all be infinitely recyclable? And there are technologies like that, like chemical recycling to turn it back into plastic monomers. And the issue with that is that it doesn't matter, because most of the plastic will never reach such a facility. It will never reach any facility because it's light and it's bulky and it's everywhere, and it costs more to pick up and transport than it is worth. So if it's more than 200 kilometers, you can put 3 tons of plastic on a 40-ton truck, and after 200 kilometers, you spent more on diesel moving it somewhere. And that's why it's everywhere. It's not worth picking up.
Isn't it also bad for our bodies?
Oh, God, yeah. Yeah, there's a very, we
had some graphics of how much ends up in your body.
Yeah, a lot of it ends up in your bodies.
Yeah.
It winds up in the food you eat. Absolutely, it ends. And it's definitely got endocrine disruption potential, which is probably the reason for the drop in sperm count since 1950. Half, the human sperm count is now half. Autoimmune disease and all sorts of endocrine disruption issues.
Yeah.
So, we can't just leave this stuff in the environment. So I'm going to quickly, I don't know where the time is. Right, okay.
No,
so I'm going to fly through. The only other solution is we could make some materials that naturally biodegrade so we don't have to pick them up and take them to a central facility. And there are materials. These are the plastic alternatives. And the problem is that, okay, here they are. Some of them are not biodegradable in nature. You have to send them to a central composting. So actually that's not a solution. And this one is bio-PE, which is basically plastic made from plants, but it has to be recycled. So those two are out. You're left with more cellulose and paper, PHA, and more glass and aluminium. Those are the current solutions. The problem is the price tag to just deal with the 360 million tons of waste that's trashed.
Exists, yeah.
You're talking $1 trillion in new facilities to make that amount of new material, as well as 55 million hectares of land so that you can grow all the crops to feed this new thing, and a 20 to 30 year timeline. So it's not that it's impossible, it's just going to take time, and we kind of need solutions now. And the solutions now have to be these 3 things. They have to be. Anytime you see a plastic solution that isn't decentralized, it will not work. It has to be carbon neutral, because we don't want to solve this problem and sort of add to a climate change issue. And we need it to be rapidly deployed, so this better be profitable, because we're not going to have international cooperation about these things. We're not going to have new plastic taxes. You know, maybe we will, but it's going to take forever. But if you have those three things, you might have a solution, or at least part of one that you can do immediately. And it cannot be that. It just can't be massive and centralized and subsidized.
There's a massive one in the Netherlands that's just gone out of business, shut down.
Yeah, and there was a huge one in Indiana too.
Yeah, they're doing it too big.
Well, and they're basically paying trucking companies subsidies to transport this stuff. So it's all subsidized. So it's just, they're basically enormous, expensive, and rare. And you need the opposite. So, which comes back to the thing that we made originally, which just happened to be the right size. We just made it small so we could throw parties. But the weird thing is that the smaller you make these types of machines, the more efficient they are, because you're only having to control temperatures of a very small volume of liquid, and you can easily control condensation temperatures. So your thermal control at a small scale is actually better. So we make great fuel. This makes petrol, diesel, and the gas is methane and hydrogen. Those are the products that we aim for. And you know, the fuel's usable straight out of this machine. It comes straight out of the machine. You can put straight in an engine, a generator, or whatever. It doesn't need to be transported for refining. So it makes everything you need on site. And it takes plastic, and no expensive catalysts. It's easy to make. We've made it sure that it's made of flat steel parts that you can weld together. OEM components. It uses car radiators for cooling, Hyundai radiators or Toyota radiators. It uses car thermocouples, all of those things. And the control system is, you know, DSP stuff, which, you know, 10 years ago would have been too expensive to put on a tiny machine like this. It was for very large installations. But now that the electronics to do really great control of tiny machines is not prohibitively expensive anymore. So, and you can put 4 of these in a shipping container, right? And it makes about 500 liters of fuel a day, and 75 kilos of gas.
Amazing.
7 minutes.
7 minutes. The other thing is it's carbon neutral. The fuel that you get out of this thing is actually carbon neutral. Why? Because it's eliminating all this transport. So all the transport CO2, and every time you buy a liter of petrol from Shell, it took 2 liters of petrol to get that liter of petrol there. So we're erasing all of that. So when you do that, yes, you make CO2 when you burn our fuels like any other petrol or diesel, but you're saving so much CO2 by replacing the existing system that this actually is, it's carbon negative. That's basically it. And these things are real. So we've been running these in 4 different countries. The one is on a French ship. It's on the Plastic Odyssey.
So imagine we could have one on all your ships, Keith. And
I just did a sweep of the ocean off Hawaii.
Yeah.
With the boom behind.
Yeah.
Yeah.
And the amount of plastic.
Yeah.
Yeah, it's unreal.
So we could turn it into fuel for you, and off you go.
Yeah, so the one is, it's on the Plastic Odyssey. That one's, so we were trying to put them on different environments to see what happened to them. The other one is in a mobile unit. This is going around northern Queensland, around the Great Barrier Reef and banana farms and stuff. So it just stops and then processes some plastic and then moves off. And it's in a sort of mobile unit.
And that could be on Kia, Julie.
But that's coastal.
Yeah.
There's one in Bangladesh, so this one's in the ocean, that one's coastal. This one is on the Padme River. It's with River Recycle and Practical Action. So this is pulling plastic out of the Padme River in Bangladesh. And then the last one, is us, where we make these machines. We're busy processing CNC waste, from plastic CNC machine operations, all the shavings from Mitsubishi. So we're doing that in Johannesburg.
Right.
And that's where we are. So we've got these machines, they're out there and they're working great.
Yeah.
And now this is where we brought in Craig and his team, because we're like, okay, how are we taking
now
these
what?
things? What's the plan? What's the go-to-market strategy for this?
Yeah. So what we did was we looked at this amazing solution and we said, well, we need a go-to-market model, we need an operating model, we need a financial model, we need an economic model, and we need a plan to take this to market. And given the kind of equipment, we said an operating license probably makes the most sense, because what you need is you need to be able to monitor the equipment, you need to consider safety, just consistency, performance, all those sort of things. So we'll add a bit of IoT to make sure that once the operator is appointed and he runs the show, he's performing effectively. So he puts in 200K, and his year one revenue is 390K, his year two revenue onwards is 580K. So from year two, he gets a 50% ROI. That offer's available today for this room. It might change. We might reduce that somewhat. And your payback period on that is 18 months. And that gives you a gross revenue, a 19% return. So it'll be an operating license with warranties and service and all of that built in. Our 5-year plan is to take the machine from where it is in R&D. So we're at this point. I was in Netherlands last week with the OSNL Energie region, where they are doing this kind of thing and looking for this kind of thing, and they have in principle committed to build a plant there. So what we want to do is build a show site that is a sales vehicle. We'll do one in Johannesburg, and we probably do one in the Netherlands as well. And then we'll roll out from there. Our initial plan was mostly SADC, the South African region, diplomatic region. But the Netherlands are saying, come here first. So money talks, I guess, so we'll see what we do there. So really we want to get to 800 plants across 4 regions in 5 years, increase the beetle production, the actual machine, to 770 machines annually by year 6. The demand, we reckon, is going to way exceed that. We've kept the numbers conservative just because it needs to be believable and achievable, especially to start. But we could have doubled these numbers. And we went through a couple of iterations where we said, no, let's just keep it real.
Yeah, I mean, I'll just add to that. I mean, these plants, one of these plants is profitable if you've got 20 tons of plastic, 20 tons of waste plastic. Yeah. And that sounds like a lot, but that's like everyone throws away about 4 kilos a month. So you're talking about any community with 4,000 or 5,000 people to 9,000 people, depending when you... These are small towns or shopping malls or industrial parks or
islands
small commercial parks. Small communities can basically they can take this huge problem and turn it into a profit center. From a cost nightmare, ecological disaster, toss it in the river kind of stuff.
Yeah,
so there's lots of locations with that much plastic.
So in terms of the 5-year, we'd have 42 million net cash flow from there. So 800 Scarab machines in 4 regions. The job creation opportunity is pretty significant because you've got pre-processing, all the sorting, collection, cleaning, shredding, etc. And then the plant as well, so 2 machines, you've got a set of operators, etc. And then all the off-take opportunities, so significant job creation. So we would have 2.4 million tons of carbon saved up initially, and then thereafter 1.3 million tons saved annually. We'd produce 408 million litres of carbon neutral fuel and 228 litres annually thereafter. 65 million kilograms of carbon neutral gas produced. The gas is worth more than the fuel, so we're doing some R&D to increase gas and reduce fuel, depending on the context. So for example, I'm also involved in a lodge project where what we're going to do is we've got letters of intent to put the machine in the lodge, take the plastic from the lodges and the surrounds and process it, and then run the Land Rovers for the game drives with the fuel, but also, of course, the gas can be used for cooking. So, brilliant circular free fuel scenario. 408.
Let's bring it to a close because we want to get questions from the audience.
Yeah, we're almost there. Plastic diverted, cash flow, you can see the numbers, 27% 5-year return on investment, and that's unleveraged. We've done various scenarios with when we should bring debt in, etc.
Yeah. So, basically we want to make the first plant, and we need 815K to do that. And then after that, we want to do the first expansion of 10 plants.
The Netherlands have said they'll put 300K down to start, and we'd look for match funding for that. Yeah.
Okay, awesome,
Thanks.
guys. Awesome. I really appreciate your comments on how we can help them scale.
Fantastic, and I'm all for clean oceans.
Yeah.
I was just in Bali, and the poor guy was going up and down the beach, raking up plastic. What I don't understand is, you said not all plastics are recyclable. Why is that?
They're often bonded. So if you're recycling, say, polypropylene, you have to just have polypropylene, which is shredded and then pelletized. And if it's got even a bit of PVC in it, it doesn't work. But if you look at most plastics, they're bonded together. You know, you'll have a layer of nylon and then a layer of PVC. And then there's other sorts. Well, that's three different plastics.
That's your biggest challenge.
That's PET, that's HDPE,
So this gets
and this
recycled
is
easily. That not easily, and that not.
And this could be could be PVC, it could be polypropylene, it's not sure. So this has to be disassembled in order for it to be recycled. Lots of things aren't disassemblable because they're actually bonded together. And the other thing is certain plastics are not recyclable because you can't melt them down. They've got low thermal, like ABS plastic. You can't take ABS plastic and then just melt it and put it back into pellets. And so you know, your computer keyboards and all of that stuff, these chairs are probably those are probably those are probably
Looks
recyclable.
a bit like
But
Bakelite.
it's and lots of plastics where you want special properties. So for example, PVC is quite hard to recycle because it's chlorinated. We can't process PVC, but because you start making chlorine gas. But then there's fluorinated plastics, which are very hardy. You can put all sorts of chemicals in. They're super amazing materials. But those also, you know, any processing of that, any heating of those, you start releasing fluorine gas and things like that. So lots of the stuff about half is not recyclable ever.
What would it take for like the marine or the shipping industry to adopt something like this and to make it a global standard?
I'm in.
Awesome.
Great.
Awesome.
Yeah.
Woo!
But as long as you don't take away from shipping coal.
And oil, I guess.
No.
Why would we?
Let's keep going. Lots of
Yeah, thank
questions.
you.
We've got Jeremy, and then we have.
Can you just tell us a little bit about the IP and how you're protecting this from people who want to copy you?
Right, so I can say two things, you can probably add on to them. The first thing is that pyrolysis as a technology is not patentable. It's very old technology. It's been used for at least 100 years. I mean, you know, making charcoal is a type of pyrolysis or gasification. So that part isn't. What is obviously patentable is the software that controls these machines, the know-how of like exactly what temperatures it has to be and what the condensation points have to be, and the scale of the different components. You know, these small machines, it's a matter of making sure that the reactor is a certain size with a certain surface area to volume, that the condensation chambers are this big to handle this much gas. So it's a combination of different things.
It's a very
and the software.
specific configuration that can be patented.
And how long is it going to take someone else to catch up?
No,
if
no.
they wanted to start from scratch.
They could. What we're trying to do is having the machine like we've got in 4 locations around the world is not enough. It's not quite enough. What you really need is, because we give them the machine and then they're like, oh, okay, now we've got to sort all this plastic and we've got to pre-process it so it can be fitted.
Yeah,
and then what do we do with the gas and the thing?
Yeah.
And then, so actually, and this is where
The
Craig's team has
secret
been.
sauce here is not just the configuration of the machine,
Yeah,
but getting
it's not just the
operating
machine.
model working,
It's the operating model.
getting the supply and the offtake working. And we've recognized that there are different contexts. The game reserve one is quite easy. The shipping one will be completely different, you know. So,
Yeah.
But we'll collect plastic and put it on the ship and process
And
it.
yeah, you want the operating model to be so profitable for the operator that it's not worth them making a machine. Just take ours.
Yeah, but the Chinese will try.
Yeah.
There's
sure.
lots and lots
There's
of
enough
questions.
plastic.
I think we have Ben Gibbons next, and then
Yeah.
James after that.
Thanks. You touched on PVC. I wanted to ask about
Yeah.
We hope that there is regulation in EU and certain parts of the world about getting rid of some of the nastier additives, phthalates, and other things like that. What quality checks need to happen around this, and does the number of additives in plastics pose a health risk or a challenge to operations?
In this process?
In the process.
Yeah, I mean, our machines don't process all plastics. We can't process PVCs, anything with a chlorinated or fluorine atom in it, we can't. We also don't process PET, we don't process water bottles. Because those kind of do get recycled. They're easy to identify, and they actually do. There's something happening there. We process mainly polypropylene and polyethylenes, those, and some polystyrene. But those ones are the most resistant to recycling. It's usually these films. They're too difficult to clean. There's no such thing as microbes that eat them. Those are the really tricky ones, and they're the least recyclable. So our solution, this whole solution, is a 50% solution. It's just available right now. Yeah. And in terms of those additives that you're talking about, inside pyrolysis, what generally happens is that they come out because they're heavy, and they usually wind up in the char that you're left with, which is about 2% by weight, which either goes into bitumen or possibly requires disposal. But yeah.
Okay, James?
I have a question about the fuel and the gas.
Yeah.
Is this what? Can I use this in my car? Can
No.
I power boats? You can power
Yeah.
transport? Or
Okay, I wouldn't put it in my. Sorry, that was me. I think I wouldn't put it in my fancy new Mercedes, computer-controlled fuel injection thing. But if you're talking about a naturally aspirated engine, yep, no problem.
So
Generators,
Generators.
Land Rovers for game drives.
Yeah, things that don't use fuel injection generally, or have very
Carburetor.
precise, just an old school carburetor, like.
So long-lived combustion engines.
Yeah.
Any last question? Any last question? I want to make just an observation. So, I've heard you mention this a number of times, and I wanted you to come because I was really intrigued with it. And I think many of us in the room have, ADD. It's difficult for us to absorb anymore because there's so much information. What I would say is just brilliant. I think it's absolutely brilliant.
Thank you.
But I think it needs to be devastatingly simple in the way, almost like Amazon one click, right? And when I was listening to that one slide about decentralized, the three things, right? That, how many times have we spoken about it? I kind of knew that, but it's just it almost needs to punch out deplasticizing, whatever the value proposition in 5 words is decentralized, it's this, because then the production of the fuel is already where it needs to be.
Right.
So you're solving 2 problems.
Right.
The fuel is local, the problem is solved locally,
Yeah.
people make money. One of the overarching themes of the whole summit is positive GDP.
Yeah.
Everywhere we go, we are the people that are solving the problem by building revenue, not going around to government saying, oh, could you please give us the money to solve the problem? Because guess what? The governments have no money, right? So let's build the
Especially in
problem
Africa.
by making money and solving the problem.
Right.
And then the energy is local. And there's something in your messaging that if you can
That
get
needs to
it
be
to punch,
tightened.
well, just punch it out. So that the first slide is, and then everybody's with you. But I have to say, it's the first time I've really understood it because it was front and center here. And it's super good. It's absolutely brilliant what you're doing. Really brilliant. So could you please thank ScarabTech.
Thank you.